Hello, welcome to my channel. Today I'll tell you about a method to reduce heating energy in areas that not used all the time. We use some space at certain times of the day and we only need heating during these hours. For example, offices, stores, hotel rooms or rooms in our homes that we use from time to time. During the time we do not use them, either the heating is completely stopped or it is put at a lower temperature. Now let's think of offices or workplaces. Work starts at 8 a.m. in the morning and ends at 6 p.m. in the evening. The heating system also starts heating a few hours before 8 a.m. and when the employees arrive, the comfort temperature is reached. When the heating is stopped in the evening, the temperature gradually drops due to the heat loss in the following 4 to 5 hours. This amount of decrease varies depending on the thermal insulation properties of the space and the outside air temperature. So, where is the heat given to the environment during the heating of space spent? Firstly, it escapes to the outside of the space to the colder environment. And secondly, it is spent to heating the objects inside. When you start the heating the space while it's cold, firstly, the indoor air, walls, tables, seats, and all the objects will start to warm up. Since every object has its own specific heat to change its temperature, it absorbs a certain amount of heat depending on the type and weight of the material until it reaches the comfort temperature. When the heating is stopped and ambient temperature starts to drop, they give this heat back. This video is prepared to reuse this heat by recovering it while the objects give this heat back. If you do not recover this heat, it will go into the atmosphere and be lost. Since the heat insulation of buildings is usually done outside the walls, when you try to heat a space, you have to heat the walls as well. In addition, the more objects there are in the space, the more energy is spent to heat them. Although you may not notice it, the heating of the walls and objects continues for 3 to 4 hours. In order to tolerate this, your heating system uses extra energy for the first 3-4 hours, both for heat loss from the walls and for heating the interior objects. If we can get this heat given to the objects back, we will have made a serious energy saving. Of course, this is not possible if this place is heated continuously. This project is prepared only for spaces heated intermittently. So, how much heat actually stored in the objects? The answer to this question depends on many factors such as the load of the objects in the place, the type of construction material used in the walls, how long it has been in use, and needs a preliminary study for the places where it will be applied. However, roughly speaking, in the space where intermittent heating is applied, the energy spent on heating the items can be between 20 to 50%. Here, I will also tell you about phase change materials, which are the subject of this project. Phase change materials are what we call PCM for short. A phase change material is a substance that absorbs sufficient energy at phase transition to provide useful heat or cooling. In this project, we will use water as PCM. The latent heat of fusion value of water is 80 calorie per gram. In other words, it exchanges 80 calorie per gram of heat while freezing or melting. The goal of this project is to cool and freeze the water in a tank with a heat pump during the heating of the room and to give its latent heat to the room, and after the heating period to remelt the frozen water by reabsorbing the heat of the interior object of the room. I want to show you a small capacity prototype as an example and measure the results. The prototype will have a heating power of 75 watts and thermoelectric module will be used as a heat pump. I would also like to point out that it will be more efficient if a gas refrigeration cycle system is used instead of the thermoelectric module. We will use an insulated water container, an aluminum heatsink for heat transfer with water, a thermoelectric module, and a water-cooled heatsink on the other side. The prototype will be operated in heating mode for the first 8 hours, during which time the water will be frozen while space heating is being done. After the heating is finished, the frozen water will be melted again by absorbing heat from the room. Thus, heat recovery will be made from the indoor objects thanks to the latent heat of freezing. Let's start our experiment now. According to these results, we can say that we have achieved an average recovery of around 38% thanks to the latent heat obtained during the freezing of water. And these results show that in space where intermittent heating is applied, this system can be used as a main heating system on its own or as a recovery unit in addition to the existing heating system. So, what kind of results would we get if this system was built with a gas refrigerant cycle system? What do you think? Please add it to the comments. If you like this video, please subscribe to my channel and don't forget to like it. Thanks everyone. See you in other projects.